Okay, our last example in this section might look a little tougher, but it really isn't. We just need to set up the problem properly, and I think you'll find it's easy once we get it set up. Find the quadratic equation y equals ax squared plus bx plus c, whose graph passes through the following 3 points. Okay, I'm not sure if you knew this, but if you threw randomly 3 points into the xy plane, there is one parabola. Oh, let me make one caveat. As long as they're not collinear, all on the same line, there will be one parabola that fits through, that passes through all 3 of those points. So we're going to find the quadratic equation. This would be a parabola if you graphed it, whose graph passes through these 3 points. So here's the hint. Write an equation for each of the 3 given xy pairs. Well, let's write down the points. The points are the xy pairs given to us. So -1, -4. Underneath it, I'm going to write 1, -2, and then 2, 5. And next to that, I'm going to write an equation. Y equals ax squared plus bx plus c. All right, so if this is, we don't know what a, b, and c are, but if this is the parabola we're looking for, this point, if we plug in this xy pair, we have to get a true statement. It has to be on this, it has to satisfy this equation. All right, so what's the y value? -4. And x is -1, so a -1 squared plus b times -1 plus c. This is going to be our equation. I'll write it over here simplified in a minute. But let's continue with the other 2 equations. Y is -2. So -2 equals a times 1 squared plus b times 1 plus c. Third ordered pair. Y is a 5 equals x is 2, so a times 2 squared plus b times 2 plus c. All right, so let's write these in a more simplified fashion. So the first one, or I'll say, could be written, I'm going to put the -4 on the other side. So what is this first term here? A, right? -1 squared is 1, so a minus b plus c equals -4. Just like that. Second one, a plus b plus c equals -2. Third equation, 2 squared is 4, so 4a plus 2b plus c equals 5. That was the toughest part. Here is our system of 3 equations with 3 unknowns. Our unknowns aren't x, y, z anymore, it's a, b, and c. All we need to do is solve the system of 3 equations for a, b, and c, and we'll have the quadratic equation. Okay, so several ways we could do it. I think one good way of doing it would be, well, we could add these 2 equations and eliminate a b, but I kind of like the idea of eliminating c because it's got 1 as a coefficient in all of them, so I'll end up needing to multiply an equation by -1 to make the c's cancel out. Let's try that. Let's eliminate, and you can do it however you want to, but I'm going to eliminate c. So I'm going to take equation 1 say just like it is. A minus B plus C equals negative 4. Equation number 2, I'm going to write it underneath, but I need to multiply it by negative 1 to get a negative C. So negative 1 times equation 2 is going to give me negative A minus B minus C equals positive 2. So as we, circled the wrong ones. The C is what's canceling out, not the B's. When we add these together, we get negative 2B. So let's go ahead and add these two equations. Well, look at that. The A also drops out. That's convenient. The C drops out, and we get negative 2B equals negative 2. And what does that tell us? B is equal to 1. Well, now we have all kinds of options to do. We've already solved for B. Let's just proceed like we were doing before. We used equations 1 and 2 to eliminate the C. Now let's use equation 1 and 3 to eliminate the C. So equation 1 I'm going to write just like it is. And then I'm going to multiply equation 3 by 2 to get a negative C here. So by negative 1. So negative 1 times equation 3. I hope that's what I said. I'm writing down equation 1, and equation 3 I'm multiplying by a negative 1. So that would be a negative 4A minus 2B minus C is equal to, and this times negative 1 is negative 5. Okay, so we took the original equation 1 up here. I guess I didn't. There, I numbered them now. Equation number 1, and then equation number 3 we multiplied by negative 1 because it eliminated the variable C when we do that. Okay? So let's add. We get a negative 3A, negative 3B minus 3B equals negative 9. Well, this was my equation number 4 if I wanted to call it that, and this would be my equation number 5. But look how trivial it is. B is a 1. Just plug it in here and we can figure out what A is. Okay, so negative 3A. B is 1, so minus 3 equals negative 9. Add 3 to both sides. Adding 3 gives me negative 6. Dividing both sides by negative 3 gives me a negative 6 over negative 3, which is a 2. So A is a 2, and B is a 1. All right, now we can just go back to any one of these three equations up here, and we should check it in all of them. Let me write down solution. Looks like 2, 1, something else. A, B, C. Maybe we can come up with C without even doing any work. Let's see. A is a 2, so that's 2. Minus B is 2 minus 1, that's 1. 1 plus what is negative 4? I think it's a negative 5. But let's verify in the other two equations that 2, 1, negative 5 is correct. 2 plus 1 is 3. 3 plus a negative 5, 3 minus 5, is negative 2. Great. So the third equation. 4 times 2 is 8. 8 plus 2 is 10. 10 plus a negative 5 is positive 5. So this is our solution. Actually, the way I should write that is it says find the quadratic equation. I need to replace A, B, and C. So the solution would be y equals, A is a 2. 2x squared plus 1 times x, minus 5. This is actually the solution that was asked for. This quadratic equation, if you graph it as a parabola, and it contains all three of these points.